Before we get started, I want to go ahead and join these areas. I've shown you how to do this in previous lessons, but if you right click on this little periphery right here, this little thing, you can, the border, boundary, whatever you want to call it, you can join those two areas together. We're going to leave the rest of these areas. There's some things that we can enable, disable to make our lives easier. For now, all I want to do is change the scene units, and I'm going to change it to millimeters. Now, this isn't super important because we're not actually making things to precision, but it's nice to repeat these steps so you can see how it's done. Now, we have a cube that's 2,000 millimeters big. I'm not going to worry about the build area. I've showed you how to do that in the past. I really don't do that very often. I only do it whenever I have very large objects that I know need to be scaled to fit inside the bed or sliced, etc., for a specific printer. I'm going to have less issues with that with the Magneto X once I get it up and running properly. But for the Bamboo Lab printers, the Prusa printers, the Creality printers, typically your bed size is going to be something like 210 to 300, something along those lines. Even a Voron, I think 350 is probably the cap for most of the kits that are out there. A lot of them are 250 or less. So depending on what you have, you may need a different build area. And so designing a build area for your specific printer is important, but it's not as important as getting these core concepts. So I'm going to go ahead and dive into this really quickly. I've wasted too much time talking about nonsense already. Here we go. So we've got this cube. I'm going to get rid of it. We don't need it. What I'm going to do instead is I'm going to add a plane. And the plane gives us a nice kind of sketch almost. We can use this to our advantage. What we can do, now I've showed you how to scale things on X and scale things on Y in edit mode, and that's all dandy. But what I'm going to show you is a little bit different. I'm going to Control R, and I'm going to roll the mouse wheel a couple of times, maybe more than that, maybe 5 times, and then we'll do the same number on that axis. So now I have a slightly different geometry. So now what I can do is delete these top and bottom rows, faces, and I can even split this and split this, do the same thing, faces. And now what I can do is I can go X and limited dissolve, and that's just going to make it one solid face. So now if I decide to bevel these corners, I don't have a bunch of geometry in my way. So I can roll the mouse wheel up, bevel these corners. Now let's say that I like the beveled corners, and my scaling's applied, so my scale is 1, so my corners look nice and sharp. If for some reason it isn't nice and sharp, and I'll just give you an example of that. So I'll add a plane, I'll bring it over here so it's out of the way. And I'm gonna, instead of scaling it in edit mode, I'm gonna scale it in object mode. So S, X, S, Y. And now if I try to go into edit mode and I want to do the same kind of bevel, look what happens. And this is happening because my scale is not set to 1. So if I undo that, go into object mode, Control A, apply scale. Now, if I go into edit mode and I Control Shift B to bevel, now I have nice rounded corners. Okay, so just something to keep in mind. If you run into that issue, now you know how to fix it. So I'm going to go ahead and delete that. We don't need that. So now I have these nice beveled corners, and I kind of want to make this a little bit angled, like a little lighthouse dog tag kind of thing. So there's a couple of ways to do this. I'm going to cheat. I'm going to Control R and put a vertex on an edge. Now, anytime you have a non-manifold edge like that, that is, it doesn't have proper geometry, it's just going to give you a single vertex in the middle of that edge. And that's one good way to find the middle of an edge. It's actually kind of, it can be challenging sometimes to line up the middle of edges in Fusion 360, especially because Fusion 360 is horribly non-performant for complex geometry. But so we're going to grab these vertexes, and if I hit J to join them, it'll actually create intersections along other edges that are there. So that's nice. So now that I have this vertex in the middle, I can go ahead and snap this vertex to that vertex with all of these other vertexes selected in vertex snapping mode. Now, there's a problem here. This vertex doesn't need to exist. So I can dissolve that vertex. Other than that, it actually looks pretty smooth. I'm surprised at how good that looks. And if we want it a little bit smoother, we can always bevel this out just a little bit more, stretch it. It doesn't taper so well. So what I can do instead of that is I can actually grab all of these, Control B, but then you run into issues. And the issues you're running into, the reason you're running into these issues is because of overlap. You can't overlap vertexes and expect good geometry. So instead, what I'm going to do is I'm going to slide this down with GG, Control B, and then I'm going to grab this one, since it's the pointiest one. Actually, now I can grab all of these, Control B. As long as they don't overlap, I can smooth them really nicely out. So that's good, but now I have to do it here, here, here. No, I don't think so. I'm not going to do that. So what I'm going to do instead is I'm going to select faces. I'm going to select this face and this face, and I'm just going to delete them. They're gone. And now I'm going to use the mirror modifier, turn off X, turn on Y, and some of my work was done for me, and I don't have to sweat it. Now we have this smooth looking little Dalek dog tag looking thing. So this lesson is about Booleans, and I haven't covered Booleans yet. I will in just a second. But I'm going to go ahead and extrude this upward just a little bit proportionally. And I'm going to go ahead and just shade smooth by angle so we get those nice rounded edges. So something to note, whenever you're 3D printing, if you have arc welding, and most firmwares do support some kind of arc welding or calculation that just rounds out these points. So you won't have these flat faces on a lot of objects unless those flat faces are very, very large, because it has, how much it can weld within a given area. So I'm going to go ahead, or within an angle as well. So I'm going to go ahead and smooth my angle, and that will be more representative of what we'll see from the 3D printer when this is done. So for now, I'm going to go ahead and stop messing with the dog tag itself. I'm going to create a new object. I'm just going to create a little tool that we're going to use to create a Boolean. So I'm going to Shift A, create a cylinder. It's way too big. Go into edit mode, select everything, scale down, scale down, scale down. I don't want to make it too big or too small. I think that's probably a good size. You need to be able to fit a key ring or paracord or something through it. So that'll be nice. I'm going to go ahead and shade smooth by angle on this guy too. And so now you have a couple of options for Booleans. Now there are different ways of achieving this. With the modifiers, we've been focused on a lot of modifiers recently. Do have a Boolean modifier, and it works pretty well, typically. We select the object that we want to Boolean, and we have our tools set aside, but we're going to select our object. We're going to Boolean, and then we can use the little eyedropper, select our tool that we want to cut with. Now, we're going to have some shading errors. You can ignore that because shaders don't go on 3D printed models. But what you want to pay attention to is the geometry here. If you look at this in wireframe view, you can see the geometry of our dog tag is actually being affected by our cutting tool. And now that the cutting tool has been selected, we can go ahead and hide it. And now we can just see the geometry of our little dog tag or keychain. And that's pretty good. That works well. Something to note, though. There might be faces that are on the inside of this dog tag, and they will affect the geometry. So we can go ahead and get rid of those. We can just delete them. And now we should have a more clean looking overview. We can shade smooth by angle again. Unfortunately, until the Boolean modifier is applied, it may not work well. So I can try using normal smooth by angle as a modifier, and it may actually clean up our normals for us. It may not, depending on your geometry. Something else to keep in mind too. If you try Booleaning an object that has inverted normals, you're going to run into some issues. And I'm just going to demonstrate that for you. So I'm going to take our dog tag and our tool, I'm going to copy them over here. And what I'm going to do is I'm going to flip the normals. My keys aren't working, and that's because I am smart. There we go. And then F3, and then flip. So now our normals on this object are flipped. And I just want to show you what it does before I show you why. So with our Boolean tool selecting this object, if I get rid of it, you notice that there's no hole like there is with this guy. Okay, so if I put those back and we switch to face orientation mode, you can see that this cutting tool is red while this one is blue. Blue indicates that the normals are facing outward. Red indicates that they're facing inward. And I'll give you a better visual representation of what that means. I'll select everything here, go into edit mode, and then in the mesh edit overlays, you can turn on the normals, and it gives you these little fuzzy hairs that will give you the direction that normals are facing. And if you look, you can't even see that the normals are facing any direction here. But if you go into wireframe, you can see that they're all facing inward, while everything else is facing outward. So if you want to be able to cut this object where its normals are facing outward, you're going to have to make the object that you're cutting with also face outward. So all we have to do is select that object, go into edit mode, and then F3 and flip. You can also go up to mesh and then normals and then flip right here as well. It's the same thing. Okay, so that's how that works. And as soon as you do that, it's going to make your modifier work properly. Now, the same thing applies to bool tool. And I can show you how that works as well. I'm going to go ahead and get rid of our Boolean modifier here. And you can see that there's no hole there now. Even if I hide this in place, there's no hole. So now what I can do is I can go into the Edit tab and Bool Tool. Now, if you don't have Bool Tool enabled, I believe it comes with Blender. And all you have to do is search Bool, and it should be here. If it's not, you can always check the docs or the repo and find it. In any case, so now you want to use Bool Tool to Boolean these two objects. Just bear in mind, this is a destructive operation. There is no way to change settings once they've been applied. You're doing a one-click operation to do quick Booleans with this tool. Now, this is very helpful when you know what you're doing, you've got some experience, and you can just cut away at your geometry, or you're really, really good at backing up your work and duplicating it and then messing with the duplicate and then duplicating the original whenever you screw up the duplicate. So if you select the body that you want to cut, select the, you know what, I can turn off face orientation mode because I think we're done explaining that. So now we can take our body that we want to cut and the tool that we want to cut with, select, I believe we select the tool first, then the body. Difference? Yes. So select the tool that you want to cut with, then the body. So I'm going to explain this now. So I'm going to go into selections in another lesson a little bit deeper. But the last object that you select is the selection. So this object is selected, this object is selected, but this is the active selection, the highlighted selection. You can select this one too. Now it's the active selection. So I'm going to select the tool that we want to cut with, select the object that we want to cut, difference, and it creates this effect. And then we just right-click Shade Smooth by Angle, and now we have a nice cut. Now there's no modifier, modifier's gone, and our operation is destructive, which means that in order to reverse this, I would manually have to go in here, delete geometry, recreate the faces, and dissolve again. Okay, not a big deal. Sometimes it's easier to do it that way than to mess with modifiers. Sometimes modifiers just give bad results and you have to do things destructively. You'll find that out about Blender, and just about every other 3D software out there kind of has that issue. Okay, but now you understand the general idea behind Booleans. Now let me show you a little bit more power behind Booleans. Let's say you want to make a dimpled surface. Why would you want that? Well, maybe you want steepling, maybe you want some kind of ingrained effect on the surface of some object. I'm going to show you really quickly how that works. So if you want to take an object like, we can take a cube, we'll bring it over. I'm going to snap the cursor to the selected cube, and then I'm going to scale the cube down on Z, flatten that just a little bit. And then what I want to do is just subdivide it a couple of times, maybe. I think that's fine. And then I'm going to select all the top faces, switch to vertexes. I'll just increase my selection. Control plus to increase the number of vertexes selected in every direction. And then I'm going to assign those to a vertex group just so I can easily select them again later. But I can also do this. I can just subdivide this top surface and not all the walls and everything else, right? So now that I've got that, I have a nice bed to carve out of. And I'm going to change the color to something, a little bit more shale-like, a little bit darker. Maybe not black, maybe like gray. Increase the metallic just a bit, decrease the roughness just a bit. Okay, so now we have a nice bed to work on. Now what I'm going to do is I'm going to create a sphere. UV sphere, icosphere, UV sphere, icosphere, UV sphere. Okay, so when we added that object, we got our menu here. I'm going to go ahead and increase the segments. Not that much. We'll do like 50. And then I will decrease the rings. I'm going for a particular distance. Yeah, that looks pretty good. One less. That's not bad. I like that. Yeah. Okay, so now what I'm going to do is I'm just going to go into edit mode, scale it down some more, and I'll bring it up. I'm going to turn off the vertex snapping, bring it up on Z. And what I want to do is I want to make sure that I'm not over the median line for this. So I'm just going to bring it down to right there because I don't want to have like a ring, like a collet around it. I just want to have the cone effect, the dimple. So now what I can do is take this object and I'm going to snap it to a corner here. So G, turn on snapping with Shift Tab, G, snap it to that corner, and it's pretty good. It's not exactly where I wanted it. I'm gonna bring it over, and then try it again. Yeah, that's pretty good. Okay, so now what I can do is grab the array modifier with the sphere still selected. And I'm just going to increase the factor a bit, just a bit. And I'm also going to increase the count, although I noticed that it's going the wrong direction. So minus 1.5. Yeah. Okay. And then the count needs to just extend beyond our plane here. Now you can hook things in with drivers and based off of the count, decrease the amount of spread and all kinds of other things, but I'm not going to cover that right now. I just want to cover Booleans and some of the power behind them. So now what I can do is I can duplicate. So if I have this modifier selected with my cursor over that modifier, if I hit Shift D, it'll duplicate it. And I can copy this value, X. I'm going to set this to 0. And then if I set this on Y, and it actually needs to be a positive value, now I have it covering this entire plate. Now I can bring the whole thing down. I meant to have it down before, but the vertex snapping offset that. And just below that median line right there. That's where I want that intersection. Okay, and now what I can do is I want to match their material just so I don't have to worry about the material differences later, and I'll just shade smooth by angle. That'll give a nice effect to it later on. Although I'm uncertain why these objects got weird flat shading and these objects got smooth and these objects are just wrong. I don't know what's happening. In any case, I'm not going to stress about that right now. We'll cover that at a later time. All the spheres that are going to affect our little surface here, they are all the right shading. So we'll go ahead and create a Boolean on our surface we want to affect. And Boolean, and then we're going to select these spheres. Now, you might notice some chonking occurred just now, but now you have this really interesting dimpled surface. Now, I didn't get all the sides that I wanted to, unfortunately. Something you can do so you can still drag around your object is you can go into the object settings, and in viewport display, what you can do is you can set this to wireframe or display as wire. And that will allow you to at least be able to see through and get an idea for what it's going to look like. So what I can do is I can decrease the space between these spheres. Let's see. Let's do negative 1.4 and 1.4 here. And then what I can do is I can center this array of objects on this plane. So I'm going to grab both of these objects, and then I think item, and if you don't have align tools, it's just a plugin that you can install that it's free. X, Y, notice how it aligned. It aligned the origin, which is still up here, to the origin of this object. So if I right click on this and I set origin to center of mass, it's still only going to have the origin here. Well, that's problematic. So what I would want to do is have some kind of offset or some other way of dealing with this. This is one of those situations, like I told you before, where sometimes you just have to apply your modifiers to get beyond this point. So I'm going to apply them. I'm going to set origin, center of mass, because there's no object there that I could snap the cursor to. Then I can X, Y, and I can get it off these other objects real quick. Things are chonking now. But you can see that it's affecting all the sides. It's affecting the corners, and it's affecting the center, and it's all centered up. So I can hide this, and now I have this really interesting plate that's got a nice surface to it. Very interesting. You can do lots of things with this. Now, granted, this is a lot of geometry. Okay, it's 11,000 verts, but I've seen, STLs with a few 100,000. So you can definitely get away with this in a slicer and 3D print this out, and it'll look great. And you can make all kinds of little tool trays with this. This will be very interesting for you to use. But that overall is the power of Booleans. Okay, so I just want to show you a little bit about text with Booleans. So you might try to use one of these other object types. If you're familiar with game engines and programming in general, you know that everything's object-based. Sometimes a lot of things derive from a common type, and so you can manipulate them in different ways using polymorphism. This isn't one of those situations. It's a little bit different here. So if you want to use text and you want to Boolean text into our little keychain here, you can. What I'm going to do real quick, just to get the white out of our eyes, it's a little bright. I'm going to switch to a matte cap. We'll use that one for now. Alternatively, if you don't like the matte caps, we can apply our material to everything and get it out of our eyes that way as well. So you have some options there. I'm going to do the same thing with this as well. So when it Booleans, it looks good. Actually, I can hide it since our Boolean looks like it is applied already, apparently. Whoops. Didn't mean to do that. In any case, I should still have this plane somewhere, but it looks like I may have inadvertently applied the Boolean, which is fine. I know how to reconstruct that geometry. I'm going to leave it as is. For now, we're just going to take our text and we're going to try to cut our text into our little keychain. So what I'm going to do is first, and I'm just going to show you the most optimal steps. I'm going to go into edit mode, type out our text, Blender for 3DP. So now that I have that, what I want to do is to set the origin to the center of mass. Before I did that, what I should have done actually is center and then middle. Now, if I do center of mass, now I could scale it down and it will remain centered. Now, what you're going to run into whenever you do this is as you scale down and you get your object nice and centered on your keychain, you can use your alignment tools here, align tools, X, Y, and you can get it nice and centered. But what you're going to run into is if the origin of your object, for instance, if I take this and I set origin to center of mass on my object, it's not going to be where it should be. So if you actually have this over here on X where you set it up, because it's hard to see whenever it's on top, it actually blends right in because it's the same exact material. If you set this up to where you want to snap your text to this and try out different texts or different objects to blend with, then you could totally do that. All you have to do is have an origin in a place that makes sense for your text to snap to and be centered on. Right now, it's actually not centered in the usable area, it's centered in the object overall. So what we want to do is take our text, we'll bring it over, we'll snap it, selection to active, we'll take our text, and it's not in the usable place. I'm going to do a top-down view with 7 on the numpad, and we'll just get it generally centered. Actually, what I can do is I can center it on the Y. That'll be good. Go back to wireframe view, and now I can just get it right on the X. I'm going to turn off snapping, get it right on the X. Yeah, right about there is probably good. And our cursor is pretty much already there. I could snap cursor to selected, and then I can switch to our other object, set origin to 3D cursor. So now, if I delete the text that's there and I want to snap another duplicate or another set of text to this object, it's going to snap into the usable area, generally already centered, assuming that our origin on the text is centered. So that'll give you a nice, easy way of just testing out multiple objects quickly. Okay, so now that we've done that and our text is generally centered, it's centered inside of the geometry of the object as well, which is fine, but I think we want to actually bring it up. So I'm going to GZ, and it's going to snap to that cursor on the Z axis only. And now what I can do is I can come to geometry, and I can extrude, and it's going to extrude from its center. So whatever value you have here, you'll have to double it if you're going for precision, as long as the center of your text on the Z is aligned with the face that you want to cut into. Just double that value to get the actual value you want. Now that we're here, I can go ahead and set a Boolean, and we can select our text, but you're going to see that there's an issue. It doesn't actually do anything. And the reason is because our text is still text. It's not mesh. So it doesn't derive from a common type that we can actually use to cut. We'll have to right-click and convert to mesh. Before I do that, I want to caution you about something. You might feel the urge to use the bevel settings. Unless you happen to be using a font, you can change fonts simply by selecting the folder for each of the types and then scrolling through and finding a font that matches that type. Unfortunately, a lot of fonts will create overlap as soon as you try to use your bevel settings. I'm going to recommend against using beveling either here or using the bevel modifier or by filleting. All 3 options will produce overlapping geometry errors and create a lot of issues. Something else to be said. Whenever you convert text to mesh, I'm just going to bring this over on the X. I can always snap it back into position. Whenever you convert text to mesh, I'm going to cover this in greater detail later, but you're going to have an issue where your mesh is not all connected. If you hit L, you'll see all linked geometry. It's not selecting the entire letter. So if you want that to work properly, you're going to have to come over, mesh, clean up, merge by distance, and you can leave it at the smallest setting and just click. Removed almost 2,000 vertexes. So now each of these letters, if I come over and I L, 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 so they're all connected now and linked up. Now if I try to Boolean this, it will actually work. But I want to show you what happens if we didn't do those steps. So I'm going to bring this over and we'll snap it to selection to active, and it's centered all the way. So we'll just bring it up. GZ. There you go. Just embed it a little bit. And now if I take this and I select our text and the normals went nuts. I'm going to add a smooth by angle modifier after our Boolean modifier to correct that. Now, if I hide this, it looks fine at first glance. But then, if you try to do other operations or bevel your text, they will go wild. So it's just something to note. You may want to merge all your vertexes before you try using your Boolean. But for now, that works pretty good. We can switch to a matte cap, and I'm going to turn on, I don't have shadows and everything else enabled for that other mode, but that looks pretty good. That's decent. Now, sometimes if you have an issue where your text has inverted normals, and I'm just going to do that for you really quickly. I'm going to merge, and I just showed you why you want to merge everything, because I tried selecting a whole letter and I got a face instead, or a set of faces, right? I don't want to have to manually select everything. I don't want to have to switch to wireframe and then try to select just the faces I want from that specific letter if geometry is too close. Instead, I'm just going to select everything, mesh, clean up, merge by distance, remove 1932 faces. Now I can come over and I can select any letter. I'm going to select this O, and then I'm going to F3, flip the normals. So now the normals are facing inward, and you can always tell which way they're facing with the face orientation in solid view, or I think in material preview as well. But you can see that O is inverted. We'll switch off of face orientation. It's very bright. And now if we look, you see the O is missing. When I flip the normals, the Boolean operation was unable to resolve it. Even if I turn it on fast, it may show up, but it's going to be imperfect. There are going to be things in slightly more complicated geometry you're going to run into. However, if you do have inverted normals, a quick way of overcoming that is just by switching to the fast solver. If you're going for precision, you can leave it on exact, but that's one way to overcome that issue really quickly. Unfortunately, I think if we apply this, our normals may have issues. I'm going to just turn on face orientation. Yes. So the normals now have issues, so they won't show up properly whenever you're trying to do different operations. And let's say you're trying, and you can already see it's darker, it's going to look wrong. You'll have issues with running some of the other modifiers, geometry nodes, etc. And you're going to wonder, why is my stuff broken? Why isn't it working? Well, now you know. That's pretty much the gist of it. It's just flipped normals. F3 activates the fuzzy finder, and then you can just type flip, and we'll hide the text, and it's good again. And we don't need that fast solver. We can use the exact solver and get the results we want. There's also hole tolerance, self-intersection, and then you have some materials options as well. But that is generally the gist of it. We can do one more thing really quickly. If we want to, we can select this entire face. So I'm just going to select one of the faces, select, and then similar, and then normal. And did it select the bottom? It did not, because the normal is facing down instead of up. And then I'm going to limited dissolve, hit I. I'm going to bring it in and inset it. And then I'm going to bring it up just a bit. And I got a bevel on the outer ring and the inner ring at the same exact depth without actually using a bevel modifier or complex operations with loop select, etc. And now our text mesh that's right here is too low. So if I just bring it up and then hide it again, we have a nice surface with a bevel and Boolean text right in there. There you go. And that's the gist of it. Now, if we want to bevel this text, there are options for doing that. Except it's not going to be the bevel you think. It's going to end up being an outer bevel, not an edge bevel. Because the edge bevel, there's too much geometry. You would need to use a paid plugin like Mesh Machine that does a lot of complicated operations to prevent overlaps and give you clean bevels. There are ways to clean up the geometry of letters in order to achieve those kinds of bevels and effects, but that is outside of the scope of this tutorial, this lesson, and most of this course, because that might also involve paid plugins or a lot of operations. Right now, I'm covering the basics of Blender for 3D printing, And this will give you that. This will give you the ability to 3D print some awesome keychains, dog tags. You could even do multicolor. If you didn't disable this mesh and you exported this mesh separately, and then imported them into a slicer using different filaments assignments, then you'd be able to quite literally 3D print Blender 430p into a keychain with a separate color, and it would probably look something like, there we go. That looks pretty good, but that's generally how translucent filament would look, although I don't have the layers pattern. There is a shader, but it costs money. Okay, guys, that's going to be it for this lesson. The next lesson, I'm going to go ahead and cover arrays and how to make use of these arrays and quickly duplicate objects, linked objects, and generally how to extract meshes and turn them into new objects that you can build on. So you can take existing meshes like this one, build onto the mesh using its own details for additional details. Okay, guys, you guys take care.